Welcome in this video where we are going to have some fun with GitHub Copilot. So in this video we will take a dataset and we'll try to retrieve anomalies from this dataset, again with the help of GitHub Copilot. So let's get started. We'll create a function called anomaly detection. Okay, data, and we would like a bit more help from Copilot. So it's not helping us. Let's see if by providing some comments we can get some code there. So remove or maybe detect anomalies in the data set provided. No. Using the sigma rule, for example. Again, not quite right. Let's see if we have other propositions. Next. No, so maybe we'll help it with by providing a sigma threshold. So what we want to do, so we'll assume the data are normally distributed, which is fine if there are a large number of data. And for example, all the data that are away from 5 times the standard deviation, we will treat them as anomalies. So let's just do sigma threshold equal to 3 by default, right? That's fine. Using the sigma rule on the provided threshold. I cannot. Maybe in the extension I can use a shortcut for next. By default there is no shortcut. Let's see. Okay, there are no other propositions. Oh, but that's great. For some reason in the previous proposition he was not computing sigma, so we'll accept that. So I think just by going to the line that helped a bit. So it's computing the mean sigma of the dataset, and therefore for every data point, if data I minus the mean is greater than that sigma threshold times sigma, then anomalies that happen I return anomalies. Okay, perfect. That's really great. That's what we wanted. And we will do import numpy as np. So yeah, that's great. So we have sigma, and for example, if we are 3 times sigma away from the mean, we treat that as an anomaly. We can try to do tests. Maybe GitHub Copilot can help us to do some tests to try this function. Test anomaly detection. Yeah, okay, why not? But that's not very helpful. Let's just accept that, and we will remove. We will do a few tests. So okay, why not? Let's keep those numbers that are quite low, and let's put a very high value, and let's see what we get. Okay, not quite right. So if data I minus mean. So the 10 is returned, but not the 1000. That's pretty weird to me. because the mean is pretty high due to this 1025. We can print the mean. Okay, it's equal to 100. And we can also print sigma. Sigma is pretty high as well. So this test is not quite great. So what we'll do, np.random.rand. So we will take 1000 data. And then so we have 1000 data that are normally distributed with a normal distribution. And then we will add data is equal to data plus 100. And therefore 100 should be an anomaly. We want to put that as a list. I will remove that. I see something. Okay. Oh, I see why we had why it was not working previously, because in the anomalies we append the I rather than the data I. So now, okay, now we have an anomaly which is 100. It's able to find it pretty easily. If we do minus 100, it finds it also. I think maybe 10 can also be considered as an anomaly. Okay, and now we have two anomalies, minus 3.78. So when we sample from a normal distribution, the data can go, we can sample points beyond 3 sigma. And this is what happened. We've been sampled this point, and there is also the 10 that is an anomaly. So perfect. We have some code that is working, that is able to find anomalies. So we see that sometimes there are some points that have been sampled that are considered as anomalies. If we put the sigma threshold to 5, we should not see those points. And we only see the 10. Okay, great. So that was it for finding anomalies with GitHub Copilot. For this code, we've had to play a bit, so to provide some detailed comments there on some appropriate parameters. But yeah, once we've been able to provide those details, all this code was provided automatically by GitHub Copilot. The only line we needed to change was this one. So very helpful and pretty convenient. So I hope this video was helpful to you. Please leave the thumbs up, it really helps. And subscribe, it will so you will see other similar content. Thank you.